Alright guys, a long time ago I put out a video called Basic Poker Math that taught you how to calculate your odds and how to calculate if you were getting good enough odds to call, facing a bluff, or to bluff if you had the opportunity. I told you how to calculate equities and how to count combos in poker. Next is the next step in basic poker math, and this is EV calculations. And EV calculations actually take us a little bit outside of basic poker math. They can get quite complex depending on what street you're on and how many decision points you have at the time of the calculation. But for today, we're going to keep it to more simple river decisions where basically it's all in or fold, or check and call all in, or check and fold versus an all in. So we're not going to be getting crazy where there's choices such as bet and have to decide what to do after a raise, or where we're on the turn where there's more streets to play, because those are very complex. So what are EV calculations? So you'll hear people say your expected value or sometimes expectation value, but basically these calculations are showing you how much your decision is worth, and they allow you to know whether you're making decisions that expect you not only just to make money, but to make the most money compared to all the other decisions you have available. And that's why these calculations are very important. So what do you need in order to make these calculations, or in order to complete them successfully? Well, I do recommend that the fastest and easiest way to do them is to just get a program like Card Runners EV, and you can just input all the information that you have, and you can let it solve it for you. So realistically, you don't have to sit down with a pen and paper and go through all of these, but sometimes it is really nice to do them yourself. It gives you a chance to work out some theoretical concepts and actually to really ingrain certain spots into your memory, so that when you come to the decision at the table, if you've actually spent the time doing it with pen and paper, when you get to the table in a similar situation, your recall is much better for that type of situation, and your intuition is much better for that type of situation. If you've actually spent a little bit of time doing these by hand, pen and paper, you'll notice a difference. But really, it's for sitting down and trying to understand some theoretical concepts. And today, I've used one example to kind of point out how you can find a theoretical concept doing this, and I'm going to actually point out one at the end of the video. If you are doing them by hand, for really difficult, complex ranges, you're going to want to have an equity calculator. It's going to make things a lot easier for you and save you a lot of time versus counting all the combos and breaking everything down yourself. And it's going to save you from potentially making mistakes when you're counting those combos. So you can get a program like Flopzilla that has a built-in equity calculator. There's a program called Poker Ranger. If you go on Google and Google Poker Equity Calculator, there's a whole bunch of them out there, some for very cheap, some for free, and some for a little more expensive. So just go out there and find what you think is going to work best for you. And that's it. Once you have those things, you are set to run calculations as long as you know the steps. And so we're going to run through an example here. And I want to point out, in my basic poker math video, a lot of people seem to draw some concern with my ranges. Maybe they were unrealistic, or the situation seemed unrealistic, or the betting pattern. These are completely fictional scenarios that are just used to practice. And I'm trying to simplify the options that are available, and I'm trying to simplify the ranges that are used in order to make the practice easier and give you a better chance to get started with it so you can understand it before you move on to the more difficult and more complicated scenarios. So this is not a practice on reading ranges or understanding certain betting patterns or lines that you use in poker. This one is just practice on the math, and then the next one is another somewhat fictional scenario, but used to highlight a theory concept. So keep that in mind when you're looking at this. This is all just made up in order to practice. So here on this board we have the king of clubs, jack of diamonds, and we have a 2/3 pot stack left. And we know that our opponent has aces, queens, and jacks. We also know that we're up against kind of a nitty opponent regarding value. And so he's not going to try to value bet queens on this board and value on himself or jacks. If we check to him, he's only going to value bet aces, and he never has any bluffs. So we know that we can check fold and have a really easy decision if he bets. We also know that he does like to bluff catch, so if we do bet, the opponent is going to call with his entire range. So the question is, do we check in this situation and fold to the bet because we know he's only betting aces, or do we bet all in and try to get some value in this case, even though we know that he has some better hands in his range? So let's look at the steps here. When you're doing these EV calculations, you need to consider all of the possible actions and the percent of the time that they occur. And all possible actions will need to add up to 100%, so that's a good check for you. When you're adding up the percents of how often everything can occur, if you're not getting 100% at the end of that, then you're missing something. Or if you're going over 100%, then you've added in something extra. For this example, you can use the combo counting strategy that I talked about and the calculating equity strategy that I talked about from the basic poker math video. I'll have a link in the description if you guys haven't seen that. And you can easily figure out where we are in this scenario. So I'm not going to do that for you right this second. I'll do it here in a second if you guys want to pause the video and try to calculate the equity that our king jack has versus this range of aces, queens, and jacks on this board of king 2275. And so now I'm going to show you the answers. So if you haven't paused it already, you've missed your chance. So the first thing we can do is we can say, well, with pocket pairs, there's 6 combos of aces, 6 combos of queens, and 3 combos of jacks because we hold a jack, so we block that a little bit. So there's 6 combos that beat us and 9 combos that we beat. So 6 divided by the 15 total combos that are available is going to be 40% that we lose to the aces, and 9 combos that we beat divided by the total of 15 combos that are available gives us 60% of combos that we beat. And you can see here I use the equity calculator to check for me. I put in the board, king 7 5 2 2, and gave the opponent his aces, queens, and jacks, and I gave us our hand that I showed. And you can see we're winning 60% of the time, and we're losing 40% of the time. So for simple examples like this, you can do it pretty quickly just by counting combos and doing the math that I showed before in my previous video. If the ranges get much more complex, then having one of these is going to be a big time saver for you, you can see. So once you've considered the percents of times that something happens, you multiply that percent by the amount of money you will win or lose if the action happens. And then you add up the results for each action. So the percent that something happens times the money won or lost, plus the percent that the next thing happens times the amount of money won or lost, plus the next thing, amount of money won or lost. You just keep doing that until you've gone through each of the possible actions based on your decision. Okay, so the next thing we do is that we write out our formula. And here I've written out the things in English in words before I put in the numbers just so you can see what everything is. So first we know that when we check, our opponent is going to bet his aces combos, so the percent that he bets. And then we know that when he does bet, since we have a 2/3 pot bet left, we can use pot-sized units. So we're going to lose a 2/3 unit. And then we know the percent that he checks, which is all those hands that we beat. And what we win here is the amount of the pot. So we win 1 pot-sized unit. Oh, sorry. Here we don't lose because we know that he's betting aces, so we always fold. Forgot my own example there for a second. So you can see that the opponent, when he's betting his aces, the 40% of the time, because we know that that's his range here of hands that are ahead of us. When he bets those aces, then we are going to win or lose nothing because we just fold. The equity of folding is always 0. And when he checks, the 60% of the time that he has the queens or the jacks, we're going to win the pot. So the value of our check is going to give us a 0.6 pot unit, whatever that is in dollars or euros or whatever you're using. So you can see here we can actually work in units based on the size of the pot without actually having to know the actual dollars or currencies that were used. And that's how I'm going to be doing this for this video, but it works just the same. If you know the size of the pot, you put in the dollar amount here, and then you're going to get a dollar amount put out here instead of a 0.6 pot units. So the other thing we have to consider is the EV of a bet. If betting is better than checking. Same thing, the percent of the time that he wins, which is going to be the 40%. The amount we lose when we bet and get called, plus the percent of the time our opponent loses, and the amount that we can win when we bet and get called in that scenario. So here, 40% of the time when we bet, we're going to lose our 2/3 pot stack that we bet. So our all-in stack, we're going to lose that. So we have to make sure to put that negative here. And then 60% of the time, we're going to win the pot plus the opponent's 2/3 pot size stack. So we get a little bit extra here because we're making some money from the opponent when he calls. And you can see here that we're winning 0.73 pot units. So clearly in this case, betting and going all in, even though he has some better hands, is going to be better for us than just checking and folding when he bets with his aces. So that is an example of a pretty simple calculation. All we did was consider the options that can happen after we make our decision, the percent of times that they happen, of the time that they happen, the amount of money that is potentially won by us or lost by us if that scenario occurs, and then we just add up each of those potential situations, and we get our number here. And that's EV calculations pretty much in a nutshell. They start out simple, but as I said, as you introduce more variables or more possibilities of raises or check raises or streets, things like that, you can see how these can get very, very big calculations. Okay, so on Twitter, at the time of recording this video, yesterday I posted a poll with a situation that is basically just giving you a setup for an EV calculation. So it says here, we have the option to value bet all in for pot or check. So we are out of position. We know, again, this is a made-up scenario, so we don't even have to talk about ranges, board textures. None of those matter because we know that no matter what the board texture is, what the ranges are, we know that in this specific scenario that I've made up, that when we go all in, our opponent is going to call us 55% of the time, and we know that of that 55%, 20% of the time, he's going to have a better hand. 35% of the time, he's going to call and have a worse hand. And then 45% of the time, he's going to have air, and air is not going to call us, so that's just going to fold. So if we check, we also know that he goes all in with a perfectly balanced range. And this is miswording. I guess I can see where this is why there's some discrepancy in some of this. What I meant with by a perfectly balanced range is of only better hands and air bluffs. So I misspoke in this. So if you're one of the people that took the poll and read it for exactly what I said here, where he's only betting better hands, then that does change some things. But what I meant was his range is perfectly balanced to better hands or bluffs. So he turns our specific hand into a pure bluff catcher. So let's do the calculations for this example. Also, one thing I want to note is when we're talking about bluffing frequency, so if you're trying to make that perfectly balanced range when you're betting a a range of the nuts, so the best possible hands versus air bluffs. I did make a video on minimum defense frequencies, and in that video, part of it talks about making balanced bluffing ranges, two value ranges. So if you want to check out that video, there's just a few minutes talking about that, and it shows you how to set up that calculation. It's really simple and easy. So in this situation, we have three options. We can check fold, and again, it's when we check, we know that our opponent's going to bet with his value hands and with his bluffs, so there's two different decisions here. And we know that there's going to be some money won or lost when that happens. And then we also know that the opponent's going to check back the rest of his air and hands that we beat. And then in that situation, we're going to have some money won when he checks back. So we know that here, this is very easy because we know that we're check folding. So when he bets, actually, because we're folding, our EV is always 0. We've decided that we just don't want to bluff catch this time. So in order to perfectly balance his range, he's going to have his 20% better hands, and then he's going to find bluffs from 10% of his air. So a total of 30% of the time, he's going to be betting, and we're folding, so we are not losing any money when he bets. And then because we have 30% here, we know that he's checking back 70% of the time, and when he does check back, because he's bet all of his better hands for value, we get to win the whole pot, and so we get that pot-sized unit. We add all this together, and we know that the EV of us check folding is 0.7 pot-sized units. So next is the EV of checking and calling, and here you can see that we've had to split this up a little bit, because now that we know that we're calling, when he bets for value, we're going to lose money. When he bluffs, we're going to win money. And when he checks, we're going to win money because he's only checking worse hands. So here you can see that 20% of the time he's going to bet pot, and we're going to call, and we're going to lose that pot-sized bet. 10% of the time when he bluffs, we're going to win the pot plus his pot-sized bet. So we win 2 pot-sized units, so that's pretty nice when he's bluffing for us. And then 70% of the time when he checks back, we're going to win 1 pot-sized unit as well. And boom, you can see that the EV of check folding and check calling is exactly the same. And here, actually, we've already introduced a theoretical concept, is that when all you have is a bluff catcher and you're playing against a perfectly balanced opponent, the EV of calling and the EV of folding should be exactly the same always, if your opponent is perfectly balanced and only betting better hands or bluffs. And so against a perfectly balanced opponent, we can see that either decision is the same. However, if you look at the minimum defense frequency video, you will see that even though it doesn't matter what we do in terms of our value, in order to not allow our opponent to make extra money, we have to force ourselves to call with these hands that basically have the same EV as folding some of the time. So we can't always just decide to, even if we know that he's perfectly balanced, we can't just always decide to fold. We do have to call some of the time. Okay, so next we've learned that both are exactly the same, check call or check fold. So now we only need to compare the third option, which is just value bet ourselves. So here is we're going to have the percent of the time the opponent calls and he wins. So in that case, we're going to lose money. The percent of the time the opponent calls and loses. So we're going to win money when he calls and loses. And the percent of the time our opponent folds, we're going to win money because we get to scoop up the pot when the opponent folds. And based on the scenario that I set up before, we know that 20% of the time we're going to lose our pot-sized bet because he has the 20% better hands. 35% of the time when he calls, we're going to win the pot plus his pot-sized call when he's calling with the worst hands. And the remainder of the time, he's just going to fold his air. And we can see that the EV of just jamming here is 0.85 pot units. So in this case, in this specific scenario, we've learned that the value of betting here is pretty significantly better than the value of checking and deciding whether to check call or check fold. So in this Twitter example, the majority of people that answered were correct, and I'm guessing some of the people that answered differently were tripped up by my crappy explanation there with the missing a few words, so I apologize to you guys for that. And just for fun, I wanted to show the EV of us checking in position. And this I'll go a little more into detail on this a little bit later. But you notice that when we check, because our opponent has lost the opportunity to bluff, the EV of checking goes up quite a bit, but we still have enough hands that we're getting value from that obviously the EV of betting is going to be the same, where he's still calling with those worst hands, calling with some better hands, and then still just folding the rest. So we can see here, though, that betting out of position and not giving our opponents the opportunity to bluff in some situations, if they're going to be perfectly balanced, is actually going to be better for us than when we have the opportunity to value bet in position. But here, still a clear value bet. The even in position, we're making more money here by the bet. So if this was our situation and we knew all these variables, whether in position or out of position, we would always want to bet here. And so that's what the IP means if you see that later, in position, in position. So the next thing I want to do is set up something that's a little more difficult and talk about how to calculate our indifference point. So the indifference point is, we're setting it up to find out when it doesn't really matter what decision we do. So we have our possible actions, and we're, instead of trying to calculate the EV of one action, we're trying to calculate when the actions have equal value. So we set them equal to each other, and then we, instead of having set numbers, we make one of them a variable, and we see how changing it affects the EVs of the decisions until we find out when they're equal. We're going to do an example here that I think will kind of show this from the Twitter example. We're going to find the indifference point. So one thing to note here is that if you're comparing the EV of folding to the EV of calling a bet or the EV of raising a bet, your EV of folding is always going to be 0. Once the decision comes back to you and it's your decision whether to fold or not, it's always going to be 0. So if we go back here, we can see why. So this is our decision here. If we've decided to check and fold, doesn't matter what's happened, the amount of money won or lost is 0. We're always multiplying it by that 0. So no matter how often we're folding, the EV of the fold is always 0 at that decision point. So if we're comparing folding to calling and bluff catching, or folding to raising and bluffing, then we can set 0 to the EV for these decisions, play around with one variable. Usually it's going to be how often the opponent calls versus folds, and run those calculations and try to figure out the break-even point. In this case, for today's example, we want to compare the EV of checking to the EV of betting. So we're going to be setting these equal to each other. All right, and so let's say that when we do bet, the opponent starts folding more dominated hands. So obviously this is our example of against this opponent, that's when we're getting value, when he's calling with those hands that we beat. So if he starts folding that, when does it become equal for us to check versus bet? What is our indifference point for that? And you can see I've gone straight to equation here instead of run everything in English words first. So we do know here, over here is our EV of checking. We've already calculated that. As long as our opponent isn't changing his strategy on this end, it's going to stay the same. So we know the EV of checking is 0.7. We always know that this is going to be the same. He's going to call with those better hands, and we're going to lose our pot size bet whenever he calls. So now we have a variable here. We have the percent of times that he calls with dominated hands. So that's our variable x. But you notice over here, I also had to move the variable x. That's because if he starts folding more than the original 35%, then the amount that he is folding overall has to go up. It can't stay at 45. So although we've only added one variable, we have to put the variable in two places in order to keep the percent of the overall options, or the overall things that can occur, to 100%. So you can see here, if this was 35%, if he's always calling with 100% of those dominated hands, 0.35 minus 0.35 would equal 0. So it just goes back to the original equation that we had the first time we calculated it. But in this case, we don't know. We want to find out when that calling frequency equals our 0.7. So how often he has to call with dominated hands in order for betting and calling to have the same EV for us. So step by step, the first thing I did was multiply these together. -1 times 0.2 is -0.2. 2 times x is 2x. These we multiply through by the amount of money won or lost. So you can see here, if you make it pot-sized units, it's very simple. We just multiply 1 through to everything. If you're working in dollars or some sort of currency, it's going to change the numbers, but it's the same thing. You just multiply it through to everything. And so 1 times 0.45, 0.45, 1 times 0.35, 0.35, 1 times a negative x or a minus x, we have to leave that negative there, so we have a minus x. Now I'm starting to add numbers together to simplify things. So 0.45 plus 0.35 is 0.8, minus a 0.2, we get the 0.6, plus 2x minus x. And you'll see here, you can also simplify this. So a positive 2x minus a 1x is just x. So we have 0.6 plus x equals 0.7. We can subtract the 0.6 from the 0.7. So we get 0.1. So we know that x equals 10%. So that this means if he's calling with any more, with 10% or more dominated hands, then betting and checking are at least equal. If he's calling with 10.1% dominated hands, then we need to start betting with our specific hand that we're holding here that beats this portion of his range. And I think to a lot of people, that's probably a pretty surprisingly low number, right? So he's calling us here, in this case, he's calling us 30% of the time. 20% we lose, we only win 10%, and it's still even to checking. If we bump that up to 11, so he's calling us 31% of the time, 20% we lose, we only win 11%. And I think that's a number that's probably pretty shocking to a lot of people here, but we can see that out of position, that's just how it works out when we do the EV calculation. So one thing I wanted to point out is notice this number that we're getting here, this 10%. It might seem familiar to you guys. If we go back, we're winning that 10% if we decide to call. And in the case of him bluff catching us, if he's bluff catching the absolute minimum, we're winning 10% if he decides to call us. So the equation ends up looking exactly the same as this one. Which is why in order for us to have the indifference point or the break-even point that we had there, he only has to call with 10% worse hands in order for the decision to be indifferent any better, and we're doing slightly better. But one thing to note here is that we're technically rooting for a fold, even though we're betting with a hand that we could consider a value bet, because it's better than checking. So let's swap that and go to in position. So same thing, we're setting the EV of the check to the EV of the bet. We calculated it before. The EV of us checking in position is actually higher than the EV of checking out of position. It's 0.8. And we're setting up a very similar equation. 20% of the time he's going to call us and we're going to lose our pot-sized bet. X% of the time he's going to call us and we're going to win 2 pot-sized bets. And then the rest of the time, which is set up by this, he's just going to fold and we're going to win the pot. And I kind of explained how we got these numbers before in the last example, so not going to go into that again. Again, we're just multiplying everything through. So we have -0.2, 2x, 0.45, 0.35, minus x. Very important to keep track of where your negatives go. So here, same thing. We get 0.6 plus x after we've added everything together. And here we get an answer that I don't think should surprise anybody, is that the EV become equal when he's calling 20% of the time. That means the EV of checking and the EV of betting is exactly equal when he's calling 50% of the time with hands that beat us and 50% of the time with hands that we beat. And I think that's a concept that most of you have heard. You only want to value bet when the range that is going to call you is 50% of the time is worse, right? And that it actually, in this case, against a perfectly balanced opponent, holds true only for in position. Out of position, we can see that the number can actually get significantly worse. But in position, we need at least him to be calling with at least 50% worse hands. Otherwise, we should just check back, and we kind of solve for that and showed that here. And that's another concept that we pointed out just by practicing some EV calculations. And we didn't have to have even a real hand to do it. So if you guys hadn't seen that before of why we need to be betting, why they need 50% worse hands or more, now you've seen it done in a calculation. And that's a really good example of how these can show us some of those concepts. So just a quick recap of what we learned. I've kind of summarized a little bit already just a second ago. But I did show you how to calculate the EV for each of our decisions in some simple situations. We also learned that calculating the EV of only one option is not enough. You can't simply stop at the checking line. Checking is plus EV, so let's just check. You need to look at all of the options and choose the best. A lot of times when we were looking at this and we calculated the checking first, if we would have stopped there, we would have missed that actually betting is our best option. So you always need to be comparing all of your strategic options and choose the one that's best for the specific situation. And versus strong and well-balanced opponents, our value ranges should be much wider out of position than in position. So again, opponents that are able to perfectly balance their bluffs and value, that aren't going to value own themselves very heavily, we need to be value betting much more aggressively out of position. And I have value in quotes here again because out of position, although it's theoretically a value bet because it has the highest EV option for us versus checking, but at the same time, we're hoping for a fold. So technically, it's kind of a bluff / value bet type of a situation. So something to consider when you're deciding on your value ranges is that check calling isn't always the good option that you think it is when you're out of position if you're playing against a very strong player. Myself included, I think it's very easy to just decide, we'll just let him bluff here and go for a check call with a hand that seems, you're at the bottom of the strong part of your range or the bottom of what you might consider your value betting range. I think a lot of people just click check call without really thinking about it. And what we've shown with these calculations is that we're actually handing our opponents EV if they're going to play a very good strategy against us. And against those opponents, instead of just clicking the check call button, we're going to be playing a much stronger game if we're actually the ones doing the betting ourselves. And we're going to be securing more of the pot for ourselves and gaining more EV for ourselves. So this does a little bit go out of the window if you are up against opponents that are going to bluff way too much, or opponents that are going to start value owning themselves like crazy. It's not on here on the slide. Value owning is a little bit tricky because usually that cancels out to zero, meaning if they're betting a hand, usually it's a hand that they would have called if you bet anyways. So the EV difference between those two decisions, if they're value owning themselves, doesn't really matter. But sometimes you might get people that end up, talking themselves into a fold when you bet, but when you check, they put you on a much weaker range, and then so they decide to bet for value a hand that might have folded. If it's that kind of value owning or over bluffing, then that's when we start thinking about check calling more out of position. So hopefully this video was helpful for you guys. Recommend working through EV calculations of your own, testing your own, and see if you can find different theoretical concepts. And yeah, any questions along the way, definitely hit me up on Twitter or in the comments of this video. And as always, guys, good luck at the tables. Catch you in the next video.